Let us discuss about the escape velocity. What is the escape velocity? Escape velocity is the velocity which should be given to an object so that it escapes the gravitational field of the earth. As we know that every mass is attracted towards the surface of the earth, so in order to get that mass out of the gravitational field of the earth, we have to do work against the gravitational pull of the earth. That work which we will be doing in getting a body from or the surface of earth to infinity, that will be given in form of kinetic energy, and from equating that kinetic energy and the work that is to be done in getting a body from R to infinity, that will yield us the value of escape velocity. So we say that a body be at a distance x from the surface of earth. We will calculate what is the work required in getting it through a distance of dx, and then we will integrate that work from R to infinity. That will give us the work to be done. We will equate that work to be done to the kinetic energy of the body, and that kinetic energy of the body, velocity from that kinetic energy of the body, will yield us the escape velocity. At a distance x from the center, what will be the force? Force will be equal to gmm by x square. So small amount of work done in getting this body through a distance of dx will be equal to f dot dx. So dw will be equal to gmm by x square dot dx. We have to calculate what will be the work done in getting this body from R to infinity. So we will integrate that work from R to infinity, gmm by x square into dx. This goes, work is, gmm is constant, integration of x raised power minus 2 is x raised power minus 1 divided by minus 1 R to infinity. Getting this one out, that is minus gmm, x raised power 1 by x raised power minus 1 is 1 by x from R to infinity, giving the limits, first the upper limit, then the lower limit. W is equal to minus gmm 1 by infinity minus 1 by R. So W is equal to 1 by infinity is equal to 0, minus minus is plus, so W is equal to gmm divided by R. So the work to be done is equal to gmm divided by R. This work is given in the form of kinetic energy, and from that kinetic energy we will get the value of escape velocity. Kinetic energy given to the body is equal to 1 by 2 m ve square, where e is the escape velocity. So 1 by 2 m ve square is equal to gmm divided by R. M and m goes multiplying 2, ve square comes out to be twice gm divided by R. So ve is equal to root of twice gm divided by R. We know that gm is equal to gr square, where g is the acceleration due to gravity and r is the radius of earth. So ve comes out to be root of twice gr square divided by r and r goes. Escape velocity from the surface of earth is twice gr. Putting the values of 2, g and r, we get escape velocity from the surface of earth is 11.2 kilometers per second. It is the escape velocity from the surface of earth. From this discussion, one thing is clear, that the escape velocity from any planet depends upon the mass of that planet, but not on the body. So if we talk of the moon's mass is less than the mass of the earth, so the escape velocity from the surface of moon should be less. The escape velocity from the surface of Jupiter, Sun and Saturn should be more than that of escape velocity from the surface of earth. Thanks.